Okay. Hey, can you hear me? Okay. I'm John Soriano, and this is not another red. Okay. First of all, I have to show you something. This is me last night. So please, don't be a rude audience. Okay. Like I have said, I work as an IT security analyst in S2 Grupo, mostly in honeypots and forensics. And for more than 2 years, I have been following Linux malware, and I have written some reports, so maybe you have read them. Why am I up here? I'm here to introduce you Yara-RET, which is a carving tool based in Radare 2 and Yara, and written in Go. Yes, in Go. Sorry for Java developers, but we're not in 1999 anymore. First, I'm going to show you why I realized that I need this kind of tool. After that, we're going to resolve a small forensics case using Yara-RET. And finally, I'm going to show you the different problems I had to deal with. So, why I need this tool? For more than 9 months, I have been dealing with some forensics cases which were based in unreliable evidences. Sometimes because the client didn't do a very good incident response, other time because they don't have a solid evidence and with only vague suspicions order a forensics. So one option when you are stuck in the middle of a forensics case is deal directly with raw data. And some forensics tools, and when you have to deal with raw data, have less flexibility than Donald Trump having sex. So I wrote a tool which solves some of these problems. Okay, the case. This case, like all this news, it's fake. It's only a mixture of different cases I had to handle along these months. And the purposes of this case is to show you how Yara-RET works and realize together why I needed this tool. Okay, the case. A computer did a request to an APT33 related IP. Our blue team detect that request and notify it to our client. After that, the client did an incident response and demands to us to do some forensics. Okay. They told to us that it's a critical computer which works as a gateway of an industrial system, and like all the industrial systems, it had access to a critical information. And another singularity that this computer has, it is able to handle with industrial protocols. So what the client wants from us? They want to know if the computer is infected and what kind of information could have been exfiltrated. So after a first analysis, we found that our client didn't do a very good incident response. And do you remember when I have said that the computer was critical? Boom. Computer is infected with generic malware. And I get like, what? This generic malware can communicate with industrial system. It was spread with an USB stick. And this malware is not related with an IPT33. Also, it has a lot of industrial libraries, and logs have rotated. So we are stuck in the middle of case. So I realized that maybe I can build a tool. Okay, yeah, a new tool. The idea of this tool is running a rule set over entire all the raw disk and extract the file which holds the offset. Carving, it's a simple job for Radare 2. So we run Yara, and when we get a match, we step back a maximum size and extract twice the maximum size. After that, I wrote a rule set with magic numbers, and we're going to run again Yara. When we get a match, we're going to resize that file. Okay, let's take a look of how it works. OK, we found a file. And when we see what kind of file is, it's a Python compiled file. Perfect. We get a file. This file, it's related with 3sys malware. If you don't know it, 3sys malware, it's a campaign from APT33. So that could be related with the request we found. But it's only a support library, and we can still know the extent of the breach. So when you look for some information about this 3sys campaign, we can get a lot of reports. So from that, we can extract IOCs. The idea was parse and files like sticks or raw files or something like that, and put it in Yara rules. After that, we're going to do the same thing again. So at this point, I thought I had the power to beat them. Let's take a look of what really happened. No. OK, I think it's like this. OK, so if we look for in that, it's again the Python compiled library. OK, so where are we? We know that it's a 3sys malware. We know that campaign it's able to communicate with industrial systems, but we only got a support library. So at this point, I thought it could be fine to look for some information about who really are APT33. At this point, the priority was the speed. But like other forensics tools do, if you spend more time at the beginning of the analysis, you could get a complex analysis, a flexibility, and correlation of information. So I wrote a shell mode. This mode, it's based on running Yara over a raw disk, the rule set of the magic number rule set. So in each match, we're gonna build a structure with a file type, an index of and a header subset. So until this point, we can get start and select file types. We can run Yara over them. We can get a hash, and we can run Radare from the shell mode. So if we open the shell, we can start all files. OK, that's a small raw disk. A real disk will take some too much time, and after this, I will talk about these times. OK, we can select a portable executable. We're going to show. OK, we have a lot of files. We can select 697. OK, at this point, we have a generic size. But if we run that, we build the real footer from the size of the headers of the portable executable. So OK, in 300 gigabytes of raw disk, will take around 30 minutes for running. Starting a file type, a single file type, will take around 15 minutes. So I wrote a safe and open information to like a project. So if you open that in shell mode, start beam. Okay, we're gonna put an output file. And we're gonna save it. Okay, now we got a JSON file with all data. So that we can open the safe that we started. Okay, so now let's go back to the case. As we know, 3C malware, it's based on Python compiled libraries. But we have a lot of legitimate files. But after an investigation, we got that these files have a company signature. So we're going to start the Python compiled. We're going to set a maximum size. We're going to set the footer. Okay, and now we're gonna. Oh no. Okay, and now we're gonna run Yara, the Yara rule I wrote with the company signature over them. So legit. Okay, now we got the legitimate files. So at this point, we're gonna unselect all files that have tagged as legit. Now we get only three files. We're gonna set the size with the footer, and then after that, dump them. So now we got the Python compiled malware, but we can still find the executable who runs all those libraries. An idea could be run a simple generic malware rule. Will get a lot of false positives, a lot of the generic malware we found in the disk, and maybe another one. We're gonna start portable executable. Okay, now we're gonna select those files. Okay. This is malware. It's a public campaign, and there are a lot of GitHub repos which have this malware. So why don't use it? And why not do it with some style? I implement in Yara-RET an SSDP implementation in Go. So at this point, we have all the generic malware. And now we're gonna run SSDP over them. Okay, we get the portable executable number 3, have a score with trilog.exe with 71. We're gonna select those portable executable. We're gonna put the real footer, and now we're gonna dump it. Okay, maybe we can get the hash. So, okay. Now, case closed. We have the portal executable. We can analyze those file, and after that, get what kind of information have they have been exfiltrated. So that's all. But I wrote another implementation in Yara-RET. Let's take a look. One, it's a VirusTotal API implementation. So if we put the API key, and now okay, now this file it's uploaded in VirusTotal. There's another features like an unselected structure check the hashes to VirusTotal. So that's an implementation of VirusTotal. Okay. Another option is another information we can have with the reports. It's the hashes. So what I did, it's with a selected file type, those file types which hold the information of the size in the headers or have a magic number for the end of the file, we can get the exact size, and after that generate the hash with Radare. After that, we can compare those information. Okay, and they have matched. I put an txt file hash, and we found that in the raw disk. Okay. Also, I put in Yara-RET the magic number, which get the magic number of the end of the master boot record. So we can open with Radare or run Yara over it. Okay, currently Yara-RET only supports 60 file types of files. But there is a repo called Yara Forensics, and owned by Shoemaker, which have a lot of interesting magic number. So I put in Yara-RET, and if you right now run Yara Forensics, there are all the information we can get from the rules of Yara Forensics. Okay, maybe there are some cases when we know what we want to do, but it's going to take too much time. Or maybe we have two computers which we want to do this similar analysis in them. So the RET supports a simple scripting, which, for example, we put the bar history. So now we start all, set the PE, show, select 543, and show it. Okay. If we look for, we can find a file with the commands, but if we open that and we would run and the file, it will run the commands we wrote in that. Another feature is the Radare is able to send data from this, with TCP. So Yara-RET uses this implementation to send selected structures. So for example, now we got this, we select the real structure. Now okay, that could be for sending files to a sandbox or to our server, or maybe you give the binary with Yara-RET to a client and the script which they have to run. Okay, what are the problems? Yara-RET have some fails in footer detection. Sometimes they are some kind of files which holds an embedded files in them, and we Yara-RET don't know when ends each structure, and we have a problem with memory management. And of course, I'm not a developer, so code could be improved. Okay, the future work. The future work, after all, it's improving memory management, improve the footer detection, add more magic numbers, improve the algorithm of detecting those structures, and check the information we got with Yara with the MFT. And of course, I know that Yara-RET takes a lot of features from Radare. So maybe in future, Yara-RET will turn into a Radare plugin. This tool will be available at my repo the next week. So maybe if you have an idea or you would like to help, I cannot pay you, but maybe, like we say in Spanish, I can pay you with carne. So thank you. And thanks to Sedor Grupo for paying the bills. If you have any question.
I have one question, Joan. Nice talk, nice tool as well. And I'm wondering why, instead of use magic numbers and trying to implement yourself this kind of stuff, why not use as a library stuff like beanwalk or bulk extractor?
Okay.
Because you have a lot of the issues that you commented. You have some of this work already resolved, I guess. So
yeah, that maybe it's building a new tool. But yeah, I think the idea of this project is only based in Yara for the flexibility that we have. So if we have to depend from another binaries, I don't know if we are still working like I had. So I don't. Maybe it will improve the tool, but I don't know if I have to think about it.
Okay. Wait.
Can see you.
Does the whole magic number finding first goes around, like, for example, do you detect the, I don't know, antivirus signature files as malicious files sometimes?
Yeah. No, it's only based in the rule set you wrote.
Okay.
Okay. Maybe the idea is you have a clue for a campaign, and you use that Yara rule set to find a related binary or a related file. It's not an antivirus.
Yeah, but for example, when you run the generic malware,
Yeah.
Yara rules, that will probably find the actual antivirus, because in the antivirus you
Yeah.
have the signatures for the.
Yeah.
Does it happen, or since you're detecting, like,
No,
for example,
this
files
signature,
first?
it's the signature I wrote. It takes a lot of false positives. I think the antivirus don't have this signature because it's a very small indices. But with the flexibility with Yara-RET, we can unselect those files or check a lot of hashes with VirusTotal or something like that. The idea is to get a lot of information because an APT campaign maybe it's based in unreliable evidences. So we don't know what is.
Okay, thank you.
Okay.
More questions? Thanks.
Okay.